All right, so in this section, we're going to be continuing talking about how to graph functions. Um, so recall that in the last notes, we talked about what the transformations did. So let's go ahead and kind of refresh ourselves really quickly on that. So remember that we have a horizontal shift if we are adding it to the x. So let's say that we have the function f of x is equal to x squared. It's a horizontal shift to the right if instead it's f of x is equal to, and we're adding it strictly to the x, so we're adding it to the inside of the function. So this would be x, let's say x plus, x minus 2 squared. Okay, so this would be a horizontal shift to the right. A horizontal shift to the left would be the opposite. So we would say instead of minus 2, it would actually be plus 2. So this would be x plus 2 squared. Okay. Then we have vertical shifts. So it's up if now we're adding it to the outside of the function. So what this looks like is we would say x squared, and we would say plus 2, and then it would be down if we have f of x is equal to x squared minus 2. Okay. And then we have vertical and horizontal compressions, which we'll talk about a little bit more in these notes. And then we also have vertical and reflections about the x and the y axis. Okay, so reflections, a reflection about the x-axis is changing the entire function. So again, looking at the x squared, it would be this, it would be f of x is equal to negative x squared. Okay, and then it's a y-axis, so I'll do that over here. So y-axis reflection if you're doing it to the inside. So f of x is equal to negative x squared. Okay. All right, so we're going to kind of walk through these, and we're going to kind of look and see what these graphs look like. So the first thing I'm asking you guys to do is to identify the parent function of the graph. Okay, so we need to identify the parent function. What that means is if we take all of these transformations away, so all of these things here out of our graph, what is left over? So if we're taking a look at this, notice that if we took the negative, the plus 2 on the side, and the plus 3 on the outside, what we're left with is the original function g of x is equal to x squared. Okay, and remember that this is a parabolic function. All right, so let's go ahead and take a look at what the graph of this original function looks like, and then we'll start transforming it. So remember that the x squared function goes through the origin, then it goes through 1, 1 and negative 1, 1. And then if I plugged in 2 for x, we'd get 4 out. So we have a point here and here. And then I can kind of draw my overall shape of our graph. Okay? And so this is what the parent function of our graph looks like. So let's go ahead and call this f of x equals x squared. Okay, now we're going to kind of look at what these transformations are going to do to it. Okay, so part B is asking so part A, I guess I should label these. So part A, f of x is equal to x squared. Part B is asking to identify the transformations. Okay, so all I'm asking for is just kind of verbalize what's going on here. So let's look, I like to start at the very far end here. So I like to do the outside first. So plus 3, what does that do? Well, it tells us to shift up 3 units. Okay, on the inside here, we have plus 2. Okay, remember on the inside of the parentheses, it is opposite of what you initially think. So it is actually going to be a shift left 2 units, and then the negative on the outside tells us to flip it across the x-axis. Okay, so it is a reflection on the x-axis. Okay, so part B is all I'm looking for there. All right, part C is to sketch a graph. So graph, right? And so we're going to use these transformations, what we verbalized, and we're going to graph this on here. So it says up 3, so I'm going to take each of these points. I'm going to go 1, 2, 3 units up, and it says to the left 2 units. So I'm going to go 1, 2 units, and I'm going to put a dot. I'm going to do that with each of these points. So now it's going to go, this one would go up 1, 2, 3, and to the right to the left 2 units. And then we have a point here, and then we have a point, let's see, 1, 2, 3, and over 1, 2. We have another one over here, okay? And then we can draw our graph. Now, this is the first 2 transformations. Now remember that it is reflected across the x-axis. Okay, so what that means is that we are now going to flip this graph vertically. So all of these points are going to go into the opposite position. So, oops. So once we're done with the shifts, we're going to flip the graph. So this one stays where it is, so the origin will always stay where it is. And we're going to flip these vertically down. Okay, and we have, let's see, this would be down 4. So 1, 2, 3, and 4. And we have another point here. Right, and then we have our graph. Okay, so save the flip until the very end. All right, and then the last thing I'm asking you to do is to identify the domain and range. Okay, so the domain, if you're using interval notation, that's fine. So remember, the interval notation is talking about how far to the left and to the right that our graph can go. So notice that we have arrows on the left and on the right, which means that it continues moving on forever in that direction. So it's going to move on forever in the left direction. So we're going to start at negative infinity, and we're going to move on all the way up to positive infinity. Okay. Now our range. Okay, remember you're moving from, the range is moving from bottom, then to top. Okay. So notice that on bottom, again, the arrows are pointing downward. So we're starting at negative infinity, and now we're moving up, and you'll notice that it kind of peaks out right up here, and we need to figure out what that y value is. So that y value in this case is 3, and because there's a solid dot here, okay, since there's a solid dot, it actually includes 3. Okay. And that's all I'm asking for in these 3 parts. So we are going to go through each type of graph, okay? And then we're going to hit on a couple of other examples. So I probably won't go through all of these examples. If you need more, just let me know, and I can kind of go back and redo some of these notes. All right. So now, again, part A is to identify the original function, or the parent function. So again, I'm going to ask you to take away all of these transformations first. Okay, so eliminate all the transformations, and what we're left with is f of x is equal to the square root of x. So this is a square root function. And remember that the square root function, again, it starts at the origin. It's going to go through 1, 1. The next point that you're going to need to kind of identify is, let's see, if I took the square root of 2, we get an irrational. Square root of 3 is irrational, but square root of 4 is 2. And then we could go all the way to square root of 9, which would be 3, and so forth. But it's just going to be this top half. So remember that there will be no negative values, okay, at least in the parent function. All right, so let's look at the transformations now, right? So again, I want to focus on the outside first, okay? So focusing on the outside, it's going to shift downward 3 units. It's going to shift, this tells us to shift to the left 1 unit. And then this is our compression or stretch, okay? Now, if it's on the outside of the function, so remember that the square root of x is our original function. If it's on the outside, it's a vertical shift or a vertical compression. If it's on the inside, so if this were like the square root of 3x, then that would be a horizontal shift or a horizontal compression. Okay, so this is on the outside, so it is a vertical shift, or sorry, vertical stretch. And remember that if it is greater than 1, it is a vertical stretch. If it is between 0 and 1, it is a vertical compression. Okay, so in other words, it's affecting the y value. Okay, so what that means, so it is a vertical stretch because 3 is greater than 1. Okay, now what that means is when I'm done graphing the these two parts, what I'm going to do is each of the y values I'm actually going to shift up by 3 instead of 1. So I guess let's go ahead and let's do this first. Let's do the vertical stretch first. So I'm going to do this in blue, and then we'll do the stretch in a different color. Okay, so I'm multiplying each of these points by a factor of 3, and I'm only multiplying the y value. So if I multiply, this one was 0, 0. Okay, so if I multiply the y value by 3, it's still 0. So I have a point here. Okay, then I'm going to look at this one. This one is 1, 1. I'm going to multiply the y value by 3, and it becomes 3. So 1 times 3 is 3. So it's going to go up to 3, and this will be my new point. Okay, I'm going to do the same thing at this point. So this was 4, 2. So remember, we're only multiplying the y value by 3, and we get 6. So it'd be up here. Okay, and then we can continue this, but there's no need. So this is our function after that stretch. Okay, so notice it's stretching the graph up. Okay, so the next thing we're going to do, I'll do this last part, and this is going to be taking the entire thing. Okay, I'm going to take this blue line, and I'm going to shift down 3 and left 1. Okay, so I'm going to take each of these points, I'm going to shift down 3 and left 1, and I'm going to put a point there. Okay, then I'm going to do the same thing here. So down 3, 1, 2, 3, and over 1. So it's going to be right here. Then I'm going to shift this one down 3, 1, 2, 3, and over 1 right there. And then we have our graph. Okay, that's all we're doing for that. All right. Now, let's take a look at part C. Part C is asking for us to, sorry, that was part C. Part D is asking for us to identify the function. Okay, so a graph. Okay, part D is identify the domain and range. So the domain, remember, is the furthest to the left and then the furthest to the right. Okay, so in this case, the furthest to the left that our graph goes is this point here. And remember, we're focused on the x value. Okay, so it starts at -1, and our arrow is going to continue on forever in the right direction. So it's going to go on to infinity. Okay, now we do need to figure out whether this is included. So we're going to put a bracket because there is a point here. We do include that 0, 0 point to begin with. Okay, and then we're going to look at the range. The range is how far from the bottom to the top that our graph goes. Okay, so the lowest point here, remember, we're top and bottom, we're looking at the y value. So the lowest our graph goes is to -3. And then again, because we have an arrow at the top, it's going to go up to positive infinity. Okay, and we do include -3 because it's in a closed circle. All right, so next we have negative absolute value of 3x minus 1. All right, so there's a lot of stuff going on here. So the first thing we want to do is identify what the parent function is. So f of x is equal to, well, the parent function, if we take all of these transformations away, is just the absolute value of x. Okay, and again, just to kind of look at what these look like. So the absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Same thing back here, because this is symmetric, and we have this kind of V shape. All right, so there's our parent function. Now, part B is to identify what the transformations do. So again, let's focus on the easy ones first. So -1 and that negative on the outside. Okay, remember the -1 is a shift down 1 unit, and that negative on the outside is a reflection. And it's a reflection because it's on the outside of the function, outside of the parent function. It's going to be a reflection on the x-axis. All right, so why don't we go ahead and do that part first, and then we'll focus on this last transformation. So we're going to do this part first, and then we'll look at what that 3 does. So we're going to shift down 1 unit, so right here, and we're going to reflect it across the x-axis. So instead of going to the right one, up 1, we're going to go to the right one, down 1. And then it's going to continue this pattern all the way down. Okay, so we have this blue graph here. All right, so that is actually the first 2 transformations that we have going on here. Now, what this one does, the 3, is it's actually going to be a horizontal stretch or a horizontal compression because it is just affecting the x. Okay, so again, if it's multiplying to the outside of our function, it's going to be affecting the y value. If it's on the inside of the function, it's going to be affecting the x value. Okay, and because it's on the inside, it again, just like it did, just like each of these, where whatever was on the inside of the absolute value, or the parentheses or the inside of the radical, is the opposite of what you would initially think. Because this is on the inside of the function, it does the opposite of what you would think. So initially, you would kind of think maybe it does a horizontal stretch. A horizontal stretch, but in fact, it actually is a horizontal compression. So it is compressing the x value. Okay, so what that means. Okay, so I'm going to do this one in red. So this is a horizontal compression. Okay, and whatever this value is, you're going to stick it over 1 or under 1. So it's a horizontal compression by a factor of 1 over a. So in other words, it's going to be, we're going to multiply each of our x values by 1 over 3. Okay, so I'm going to take a look at each of these x values. Okay, so right here we have 0, 0, -1, I guess. It doesn't really matter. We're not focused on the x value. So 0, -1, we're not focused on the y value. Okay, multiply 0 by 1/3, we still get 0. So our graph is still going to be right there. Okay, then we're going to take a look at this one. Okay, so this one is 1, -2, right? We're going to multiply the 1 by x, no, sorry, by 1 over a, which we get 1/3, so somewhere right in here. Okay, then we can do the next one. So this would be 2 to, what would that be, -3. Okay, multiply this one by 1/3, we get 2/3. So somewhere right in here. Okay, and remember that this is symmetric. Okay, so we do have these graphs going through here. And then we'll stop here at this one. So this one is 3 comma -4, multiply with 3 by 1/3, and we get 1. We have this graph here. So we have a nice horizontally compressed shape. So again, it's kind of like taking a vise, and it's kind of pushing these in by a factor of 1/3, right? So it's pushing the x-axis in on itself. Okay. All right. All right. So let's look at part D now. Okay. So part C is just to graph it. Okay. Part D, though, is asking for us to find the domain and range. So the domain for this function, the arrows are pointing to the left and to the right. There's no space in between them, so it's going to go from -infinity to +infinity. And the range is going to go from, well, it's pointing downward, so it's going to start at -infinity, and it's going to continue up to the peak, which is at -1, and we do include that -1. Okay? All right. I think we will cover all of these just to make sure that we're 100% on what we're doing. All right. Now, we have this function, okay? So we need to identify the parent function, okay? Again, taking away all the transformations, and you'll see that our parent function is f of x equals x to the third power, okay? Part B is going to ask us to determine the transformation. So the first ones I like to look at are the pluses and minuses. Okay, so on the inside here we have -1, so that is actually a horizontal shift to the right 1 unit. Then we have this negative on the outside, so it is a reflection on the x-axis. And then we need to look at this 1/2. So this time I'm actually taking the function and I'm multiplying to the outside of the function. Okay, so because we're multiplying to the outside of the function, it is going to be either a vertical stretch or a vertical compression. Remember, it is a stretch if if the number, so we're going to call this a, is greater than 1, and it is a compression if a is between 0 and 1. Okay, so in this case, a is between 0 and 1, so it is a compression of 1/2. So we're going to take each of our y values, we're going to multiply by 1/2. So let's go ahead and graph this function first. Okay, so it goes to the origin. Okay, we plug in 1, we get 1 out. Plug in -1, we get -1 out. We plug in 2, we get 8, so way up here. We plug in -2, we get -8. So we have, this is our parent graph. Okay, so this is the graph x cubed. Right, so now we're going to go ahead and do all these translations, right? So we're going to take a look at this one first. Okay, so it's going to shift to the right 1 unit, so one unit each of these. Okay. And then it's going to be a reflection on the x-axis. Okay, so instead of, so this one, our point here, so I'll change color so we can kind of see what's going on. Our point on the x-axis stays the same because we can't flip it there. Now, this one will flip down here. This one flips up here. And then we have up here and down here. And then we have our graph. Okay. And then finally, we have our compression. Okay, so I'm going to go ahead and erase the ones that we don't need. So we're kind of going through this step by step. Okay, so now we're going to look at the compression. All right, so I'm going to change to purple. If we focus on where we started the origin, this was, so remember we're multiplying this just to the x value, just to the y values now. Okay, so this is 1, 0. Multiply by 1/2, by the y value by 1/2, we get 1, 0 still, right? Then we do the same thing to this one. Okay, so remember that this is, let's see, this is 2, 1, multiply the y value by 1/2, and we get this. Okay, do the same thing over here, we get this. Right, and then we're going to take a look at this one. This one is 3, -8. Right, we multiply the y value by 1/2, and we get 3, 4, or -4. So right here. Okay, do the same thing to the top point over here, and now we have our graph. And remember that this should be shorter or fatter than our previous graph. Okay. All right. Now moving on to part D. We have, we're looking for the domain and range. So the domain is going to, notice that it's going to be pointing to the left and to the right. So our domain is from negative infinity to positive infinity. And our range is, again, now we're pointing up and we're pointing down. Okay, so we're going from negative infinity to positive infinity. Okay, and really any cubic function, so any function with a to the third power, is going to be from negative infinity to positive infinity for both the domain and for the range. Okay? All right, let's take a look at this last one before we move on to transforming them by hand. All right, so this one, again, we're going to focus in on taking away all of the transformations. So I'm going to take this, this and this away, and we're left with what we call the reciprocal function or a fractional function. Okay, so the reciprocal function is probably the most difficult one to actually graph. Okay, so what I want you to kind of focus in on here, and I'm going to do this in red, is the this is called an asymptote. Okay, an asymptote is a portion of the graph that the graph not actually cross through. Okay, and notice that the reason it can't cross through this axis is because we can't have that x is equal to 0 in our parent function. Okay, so this is actually what's going to be shifted, right? And so when we graph these, when we graph this, and especially the parent function, it's going to start here and here. So this is really the only point that you're going to be able to graph. And our line is going to get really, really close to the y-axis. It's going to level out right here at 1, 1, and it's going to continue moving on forever in the right direction. Okay, and it's going to do the same thing over here. Okay, so it's going to get really, really close to the x-axis. Oops, wrong color. It's going to get really, really close to the x-axis. It's going to level out at -1, -1, and it's going to shift downward. So this is, again, what the parent function looks like. And what you're going to be transforming here is the vertical and horizontal asymptotes. Okay, so that's what we're actually going to be moving. All right, so part B is asking for us to figure out what the transformations are. So remember, if I like to start with the one on the outside, so this is pretty easy. It's -2, so we know that it's a vertical shift down 2 units. Then this is actually affecting just the x value. So remember, if it's adding to the inside of the parentheses, think of the bottom here as the inside of the parentheses. Okay, so if it's adding to the inside of the parentheses, it is a horizontal shift either left or right. This is a shift left 2 units. And then this negative on the outside tells us that it is going to be a shift, or sorry, a reflection on x-axis. Okay, so it's a reflection on the x-axis. So it's going to flip upside down when we're done with this. All right, so what I want you to do with these is simply move the asymptotes and then we'll regraph it. Okay, so remember the asymptotes are right here. It says this cross, so that's what we're moving. Okay, so it says down 2, so we're going to move the cross down 2 units. So right there, and then to the left 2 units. So it's going to be over here. So here's our new horizontal and vertical asymptote. Okay, if you need to, you can always just draw in a line. If you need, if you're doing this without colors, I would suggest using dotted lines. Okay. Okay, so now we can go ahead and graph the point. So I'm going to graph this in blue. Okay, so the red line is not actually there. It's just kind of a placeholder. And this is a we'll go ahead and graph this part in blue. So remember, it goes to the right one, up 1, right? So to the right one, up 1, and then it's going to the left one, down 1. We're going to put a point here, and it's going to look something like this. Okay, so these aren't going to be perfect. We'll talk about, we're going to actually avoid vertical and horizontal compressions with these because they are a little bit more difficult. Okay, but we'll slowly go into those. So these are the first 2 transformations, right? Now this last transformation tells us that we're going to flip it. Okay, so it's going to flip across the x-axis. Think of this as our new x-axis. Okay, so if it started up here, it's going to now be down here. If it started down here, it's now going to be up here. And so when I graph this, the orange line is the final version of what our graph should look like. Okay, so there were several transformations here. This is by far one of the more difficult ones because we're dealing with the reciprocal function, and we're not super. I know that most of us aren't super comfortable with fractions already, but this is the extent. So this is about the most difficult that we're going to make the reciprocal functions for right now. Okay. Okay. So now. So before I've been giving you guys the functions, and we come up with the graph. So now I'm going to give you the parent functions, and I want to come up with the final equation. Okay, so we're going to take a look. It says it is a in number 6. It says it is a compression horizontally by a factor of 2. So if it's compressing horizontally, that means that that is going to be affecting just the x value. Okay, so it is only affecting the x value. So we're going to go ahead and leave this one for the end. Okay, actually we can go ahead and do this. All right. So it is horizontal compression. Okay, so if it is a compression, it is going to be on the inside. So let's go ahead and call this. We'll call this g of x equals. Okay, so it is only multiplying the x value. So here is the first compression, right? Okay, so number 2, it says it is a reflection across the y-axis. Okay, so again, that is affecting, because it's the y-axis, it's affecting the inside of the function. Okay, so we're going to say g of x is now the square root of negative 2x, right? Because we're affecting just the x-axis, or just the y-axis. And then we are going to translate or move to the left 2 units. Okay, and again, this only affects the x value. Okay, so the last thing we're going to do is we do have to change this to parentheses, right? So we got g of x is equal to the square root of negative 2, and it's only affecting the x value. Okay, so this is going to be x plus, right? So left is plus 2. Okay, so this is the final function that we're looking for. Okay. All right, so let's try another one. All right. So we've got, let's see, we've got compression horizontally by a factor of 3. So we're multiplying, because it's horizontal, it's going to be multiplying just to the x term. Then we've got a reflection about the x-axis. So this is going to be changing the outside of the function, and then translate to the left 2 units. So this is going to be a plus 2. Okay, so let's go ahead and take a look at this. So let's do the first part. So it says compression horizontally by a factor of 3. So it's going to be g of x is equal to, this would be 3x squared. Okay, so again, we're only multiplying to the x. So because of that, we need to put this in parentheses. Okay, without the parentheses, this would be a vertical stretch. Okay, so this would be a vertical stretch if this did not have the parentheses. So be careful and make sure that if it's just affecting the x value, put parentheses around it. Okay, then it says reflection across the x-axis. Okay, so a reflection across the x-axis is going to change this from a positive function to a negative function. So x-axis, we put it on the outside of the function. Okay, and then it says it's going to translate left 2 units. Okay, so again, this only affects the inside of the parentheses. So I'm actually going to write this last step here. So g of x is equal to negative parentheses 3, and this part again because it's left, it's only affecting the x value, so it's going to be x plus 2. And then close parentheses, squared. Okay, so again, horizontally compressed. Okay. Then we have reflect across the x-axis, that's this. And then we have, we'll do purple. Left to that effect, that's this. Okay, so that's what we're looking for. This is the final equation. All right, just a few more. All right, so we've got x cubed, okay, reflection across the x-axis. Okay, so if it's across the x-axis, remember that we change the outside of the function. Okay, so we've got, let's see, this would be g of x is equal to negative x cubed. Okay, translate left 2 units. Okay, so that affects the inside. So left and right affect just the inside. So this would be negative x, left is plus 3 cubed. And then the last step is going to be translate up 2 units. So up and down is outside. So we're going to add this to the outside. So we've got g of x is equal to negative x plus 3 cubed plus 2. All right. And again, there we have it. All right. So I'm just going to kind of walk us through these again. So we're going to expand. So in our case, I've been talking about vertical stretches. So this is going to be stretching it vertically. Okay, so a vertical stretch by a factor of 3. Then we're going to reflect across the x-axis and then translate down 3 units. Okay, so I'm going to try to do this all in one step this time. All right, so we have a vertical stretch. So that's going to multiply through the outside of the function. Okay. Reflect across the x-axis, that's going to change the outside of the function to negative. And then translate down 3 units. So up and down, remember, also affect the outside of the function. So it's going to be negative 3x cubed. And then down would be minus 3. And there's our function. Okay. So again, negative, reflect x-axis, 3, expand vertically by a factor of 3, and then the minus 3 is going to be down 3. Okay. All right. So last one of these is going to be asking for us to take a look at a reciprocal function. Okay. So again, so this time we're going to compress horizontally. Okay. So again, horizontal affects just the x value. Okay. So this would be 3x on the bottom. Okay. Reflect across the x-axis. So x-axis is going to affect the outside, right? And then translate to the left 1 unit. So this x on the bottom then becomes x plus 1. Okay, that's all we're looking at here. All right. So let's take a look at these last 2 problems. All right, so it's saying identify the parent function and then write the equation of the function given. Okay, so looking at number 11, this is a parabolic curve, right? So because it's a parabolic curve, we know that the parent function is just f of x is equal to x squared. Okay, let's go ahead and identify the parent function for number 12 as well. So number 12 is going to be f of x is equal to, this is a reciprocal function. Okay. Now, number 11. So back to number 11, let's go ahead and take a look at the transformations. Okay. So notice, whenever I'm looking at graphs, I'm going to focus in on the origin. Okay. So notice that it shifts to the left 2 and down 1. Okay. So left 2 and down 2. So left 2, down 2. Okay. And then we're going to look to see if, so it's also flipped. So remember that the original function looks something like this, right? This is flipped. So as a vertical, so I guess it's a reflection. on x-axis, right? And then the last thing we need to check is to see if there's any compressions or stretches. Okay, the way I'm going to do that is simply by checking the first point. So I'm going to say from the origin, right? So from the peak, I'm going to say it should go to the right one and down one, and it does. So there's no stretches or compressions that we need to worry about. Okay, so again, this comes back to you need to know what these graphs look like, or the original graphs look like, and kind of be able to point out some of the key features. All right. So now I'm going to go ahead and write my function. So g of x is equal to, okay, it says to the left one. So we know that on the inside of our function it's going to be x plus 2 squared. Okay. We said it's up to, down 2, so minus 2 on the outside. And it's a reflection on the x-axis, which means that we're going to put the negative on the outside. Okay, if it were on the y-axis, we would put the inside in parentheses and put a negative on the outside, but this is on the x-axis. Okay, and that's all we need to do for these. This is what I'm looking for, is the final function. Okay, now let's take a look at this next one. This one's going to be a little bit more difficult. Okay, so remember that the original crosshairs that we're looking at is actually right here in the middle. Okay, so we shifted our crosshairs up by a factor of 1. So we shifted up 1. Okay, we did not shift this left, nor did we shift it right. Okay, so we did not flip this at all, or shift this at all. Okay. Now we're going to take a look at, I'm going to go ahead and scroll back up here and take a look at the black line. Okay, so notice that here, the black lines are up here and down here. Okay, however, down here, we flipped them. So it's no longer up in this corner and down in this corner. We've actually flipped it here and here. So this is a, we'll call this a reflection on x-axis. Okay. All right, so the last thing we're going to take a look at is where these points are. Okay, so remember that from the origin, it should be, the first point that we're looking at should be from, up 1 and over 1, so it should be right here. Okay, same thing down here, so it should be to the right 1 and down 1, so it should be right here. Notice that they're not. Okay, and we're going to kind of eyeball this and figure out where it is. So if it is not in the center point, okay, we need to figure out where it actually crosses through here. Notice that this is about halfway. Okay, so it is affecting the y value. Okay, so it's about halfway between these two, and it's affecting the y value. So it's actually a horizontal compression of a factor of 1/2. Okay. So that means, so it's a compression of a factor of about 1/2. So in other words, we're multiplying the entire function by 1/2. Okay. So when we write our function, we've got g of x is equal to, okay, up 1, that affects the outside, so we've got 1 over x, so we'll kind of write it like this. So up 1 would be plus 1 on the outside. Okay, reflection on the x-axis, that's a negative on the outside of the function. Okay, and then a compression of 1/2 is going to multiply this function by 1/2. Okay, and what we're left with, let's go ahead and simplify. So remember, multiplying fractions, you just multiply across, right? So we've got negative 1 times 1 is 1, 2 times x is 2x, plus 1. All right, and so this is what our function is going to look like. Right, so this is the actual graph of the function. All right, let me know if you have any questions, guys.